So there's a minimum requirements. That means that you not be forced to put into a certain box, because the way engineering is, you have to think outside the box and you're solving a problem. You understand that? So you can't really be pinned down like that, but there's a minimum requirements for survey practice and the plans to be kept at the mine. Is that okay? All right. Survey plans are plotted using grid coordinates. I think we know what grid coordinates are, which may be on a national or international system, or may be a local system used by individual. Here we're talking about coordinate system here. Are you okay? So if I ask you a question, if ever I ask you a question about this, I want to know your knowledge about coordinate systems. And I don't get off responses from you, but I believe you understand the differences between a local coordinate system, some kind of national coordinate system. If you talk about international system, but what we are talking about is a geographic coordinate system. It's a coordinate system that people can relate to outside Ghana. Are you okay? Example will be the UTM, Universal Transverse Mercator. We will not talk about it in this class, but maybe you understand the idea of coordinate system, these pairs of numbers. You know coordinates. So that is how we plot the survey plans. The reason the students are supposed to pay attention to a lecture is that, and why we call it a lecture is because I can ask you a question and you need to think outside the box and try to understand what I'm saying. You know coordinates already, but when I ask you a question with regards to how survey plans are done, I want you to just think survey plans. Are you with me? All right. The system which system are we talking about? The coordinate system. So there's something called coordinate reference system. Are you okay? That is what we are talking about. The coordinate reference system, or the coordinate system. Whichever we talk about, you need a particular coordinate system to work it out, but to plot the survey, the mine plan. Okay, so it's subject to the mining regulation, and I've told you why we need the mining regulation for this one. So I can create a scenario. Are you okay? And in the scenario, you are the mining, you are the engineer. Are you okay? And you are supposed to do an excavation. Remember, in a course like this, engineering survey, you should think like a surveyor. So your answer should be given like as if you are a surveyor. That is how it should be. So you should know about coordinate system, control. Are you with me? Etc. All right. One, comprehensive surface plan. Are you okay? So with a comprehensive surface plan, this is what we will call the topographic map. Normally, if there's no mining and someone said, I need you to give me a topo map. That's what the short form of it, topo map. It is what we are calling comprehensive surface plan. Why? There's a reason. Okay? There's a reason. Why we call it comprehensive surface plan? Sometimes I think we make learning very difficult, isn't it? For ourselves, because we don't look at it closely. Why? Because there is something else. The underground is there, so you can't just say plan. Are you okay? But you can actually get a planimetric representation of everything that's going on underground. So comprehensive surface plan, and that should include contours. What are contours? Okay, what are contours? Benjamin, what are contours? Benjamin, what are contours?
Can I try, say?
Yes, Benjamin. What are contours?
Say, can I try?
You are driving.
I think, can I try this helicopter?
Okay. Try. Of course. But if you get it wrong, this is not Sunday school. I'll tell you.
No.
So go ahead. What is it? Yeah.
Yes. Contours are imaginary lines drawn on maps, joining places of equal height above sea level.
Perfect. If I ask students who are studying geomatic engineering, surveyors, they probably wouldn't have given me such a good answer. So you have my recommendation, right? Yes, I'll give you a commendation. That's good. Very good answer. Of course. So we want to have contour lines. They are always needed for representation of the relief. Are you okay? So what is the relief? The relief is relief is when, let me say this funny one, then we can get serious a bit. Relief is what happens to Tom. No, Jerry. Jerry is the mouse. When Tom, the cat, hits his head with a hammer. Are you okay? Then you see something popping out. Are you okay? Anyway, that's a funny one. I don't know if it's even funny. But anyway, so you need a contours to show all those objects that seem to have elevated, are you okay, themselves above a datum. So Benjamin mentioned the mean sea level. That is a typical, that's one thing everybody should just put in their mind. If you are not a surveyor, don't worry about any other datum. Think about the mean sea level. It's a datum. It's okay. And it's imaginary, the same way the contour lines are also imaginary. So you can actually see a contour line. There is good. Oh, can you see the contour line? Can you see it? Like nobody should really fool you like that. Prominent natural features. So anything that's prominent, catch, just get it. Maybe there's some, I don't know, shrines, some pick it. Are you okay? When you do a survey, your surveyor should do that if you're not a surveyor. Are you okay? So you need to capture all that natural water courses. You shouldn't be saying, but we are here to do mining. Are you okay? These are reference points. Man-made features, buildings, get them. You need to get them on the plan. Roads, fixed plants. So when we say a plant, always think about generator. Think about that, or such, equipment. Power lines. Fixed plants means that you can have a movable plant. If you work on a construction site, you know that they are movable plants. Someone needs to do some welding. Are you okay? And how do they get it done? They need power to do it. And so how they need a plant. So you put in some diesel, hey, there you go. And you are working. Okay, so power lines should also be captured. Substations, okay. Talking about power, electricity substations. Water storage facilities, very important to get them on board. Pipelines, okay. In fact, this is a very generous list. Why am I saying that? You are being told, because if you're not told, then you just be thinking, maybe I shouldn't get it. Are you with me? All right. That's one challenge for every beginner. If you just start an engineering profession, you wouldn't know how much to do something. Are you okay? And sometimes you are in a hurry to give an answer. That's another thing. So to become an engineer, you need to know how to say, wait for me, I'm coming, I'm going to think and I'll come back to you. This is my free gift to every student that I'm teaching. It's okay. Don't be in a rush to give an answer. Please, engineer, can you tell us whether we should move this to the right or to the left? Tell them you want to think about it, give the thoughts, because that's all you are there for. All right, going to do some calculation. I'll come back to you. All right, don't be in a hurry. So all stockpiles. So the ore contains the gold, all right, the diamond, the lithium, whatever it is. Stockpiles of that. Waste rock dumps. Okay, so there's something. The word dump is used a lot. Yeah, in the mining sector, the mining area. Please, I seem to be spending time on this. You think, okay, then it means he's going to ask a question about it. I keep saying to you, no, don't think that way. It's a lecture. So you can see there's a tailing dam. So the tailing dam, kind of like the waste going in there. Are you okay? And then you need to construct it. You are the engineer, all right? You need to work out the volume. Remember that the volume calculation, that is what it's for you to say it can take this amount of water. So once you've done it and you say, okay, so this is where we got to have it, then you can go ahead. Yeah. So you work in a team in which everybody knows the importance of different aspects. Mind workings present on surface should also be captured on this plan. It's very, it goes without saying that it's a mind plan, for crying out loud. So it needs to have the mind workings, the things you are doing concerning, we are mining, yeah. Miners always go with some hammer and some tools, chisels and stuff. All those activities are mind workings. Present on surface, the things you do on surface as part of the mind should be captured. This is not my meaning of this mining open, yeah, pits. So please, guys, ignore that. That's a spelling mistake. It is not meaning, it's mining. It's okay. All right. Open pits, yeah. Trenches, yeah. And other surface. Okay, so I think here, yeah, rather I'm not getting it right. So we need to look at surface mining as well. It's not just going underground. Excavations, shafts, winzes. You can go and check it out. Check your dictionary and look what it is. Find interest in this. If the engineers are interested in the activity, how can you, yeah, be designing for it? Surface funds. Well, if there's anything like that, actually anything you see out there that's related. Areas of actual expected subsidence. I talk about subsidence and it's coming like twice. In that image, you could see the subsidence area. It means that's the area you are likely to be killed. All right, that's not funny. Expected subsidence. Okay, mining license boundaries. I think we talked about this already. That you just can't go beyond certain lines when it comes to mining. You just can't come. I'm here to mine this area, and I'll be nah. All right, okay. There's a case where a town was being sold, a whole town, and the people didn't even have a clue. Are you okay? It took the youth to discover that, you know, samples of soil had been taken, all right, and they were in the lab being tested. In fact, what we call the assay was being done on it. In other words, you are testing for the minerals. But how much gold is in it? How much are you getting that? All right. Areas of actual substance. We talk about, okay, so mining license boundaries, position of boundary beacons. So we need to look at that. We need to know where we can go beyond. It's very important. So specialized plans, detailed plans of tailings dams, plans for environmental management systems showing, for example, effluent discharge points, volumes, sampling point, etc. These things should be made available. Otherwise, we take the line, you stop you from doing the work. So that is why it's important. So every day you're working, that's the kind of thing it is. You can't be there and say, oh, I'm done. I've finished with the plan. I just want to sleep. We don't do that. Are you okay? All right. Benjamin's hand is up. I don't know if he is intentional or it's not. If it's not, Benjamin, talk. Please. If it's not intentional, I'm lowering your hand. Okay. So let's continue. I always want to see my face in this thing. Okay, wait. Right, so surface plans may be at different scales. So if you hear and don't know what the scale is, for every map, it has one important property, and that's the scale of it. Is okay. And okay, so Benjamin, if you have a question, ask me. Keep on putting up your hand. I keep lowering your hand, you keep raising it. Or is it a mistake? Okay. All right. Let me not see your hand up again. All right. So you can have 1 in 250. Okay. What can you see on 1 in 250? Elikem. What can you see on a map of 1 in 250? Benjamin, I think it's a mistake on his phone. Elikem, what can you see? Yes, Elikem, what can you see on a map of 1 in 250?
A map of 1 and 250.
1 is to 250.
Oh, okay. It's what I can see means the any reading I take or any measurement I take on the map represents 250 times the on the ground.
Exactly. So what kind of things are we looking at? So it means if you measure like 2 millimeters, you are getting what? 250 millimeters, right?
Yeah, times
On the
250
ground.
millimeters. That on the ground, sir.
And if you take it to centimeters, what are you getting? 10
Divided by
millimeters
10,
make
sir.
so that's 25 centimeters, right?
Yes, sir. Yes, sir.
So when we measure 2 millimeters, we'll be looking at something on the ground, which is about 25 centimeters. So what kind of object are we looking at? Which is of a width of 25 centimeters.
Object.
What object is about 25 centimeters width?
Hey, sir, I'm a bit lost.
Give me an object with a dimension, a width of about 25 centimeters on the ground.
An object.
Sure. Benjamin, you are in the engineering class. It's an object. We deal with objects. Don't forget that. Are we not training as engineers?
Yes, sir.
Yeah, so objects, sizes of objects. You should have an idea. Is that okay? Someone says we are going to drill. You should be able to know we'll be drilling the diameter of the drill, the end of the drill is this size. That's what engineering is about. It's okay. In reality, that's what it is. So you need to appreciate dimensions. If someone says 2 millimeters, you should know how it looks like. Are you with me? You should be able to guess 1 kilometer so that if you are doing a road project, you can figure out where you are. You want to send someone 1 kilometer away, you don't come back and then you sack the person from the workplace because you are getting emotional. But then you know how 1 kilometer looks like. Are you with me? So we need to get real. Okay, so but thank you for your answer. Yes, that's what the scale means. It means that very small objects can be seen on the plan. That is the point I wanted to make. Because for a 2 millimeter measurement made on the plan, the object is 25 centimeters, which is really, quite big. It's about this. Whether you believe it or not, yeah, something like that. It's quite 25 centimeters. Let's say it's 200 centimeters, 100 centimeters. Okay, 50 centimeters. And then 50 centimeters, half of it is what, 25. Like you have to be able to like figure out, quantify it somehow. So everything, you go and do a calculation. All right, some of the things you have to do your head. All right, so yeah, ignore the word ASM sector, but obviously scales, we can have small scale, medium scale, large scale. Is okay. So if we are dealing with a large scale, example be like 1 in 250, but so for most plans for mining, they will be large scale. Are you okay? All right. All right. Plans may be projected onto multiple sheets when, of course, and these should be indexed to each other. All right. Depending on whether you want to look at a couple of mining pits, you have one project at Asankragwa, you have another one that's within the same region. Are you with me? And you want to like have a plan for them and then look at it. You'll not be looking at it at a larger scale anymore. You'll be looking at it at a smaller scale. Equia, I hope you understand what I just said. Are you there? Okay, I know your network is bad, so you can't say much. Yeah. Okay, so basically we need to look at underground plans. Okay, underground plans, UG mines. In fact, UG means underground. All right. Assay plans. So we have the surface plan. Okay, we have the underground plan. Are you with me? Then we have the assay. What did I say the assay was? So the assay will show you what? Okay, Akria is responding here. I hear you say, okay. Yeah, I also hear you, okay. You are my favorite in the class. Even though the network is not working. I understand. Okay, so assay plans, especially on gold mines, like we said, the assay but what they call a fire assay. You take the example, they're going to test it in the lab. Are you okay? So on gold mines, you want to have the results from the sampling. You plot it on the map, so you can see, okay, there's more of it here, more of mineralogy. I get that. All right, that's the idea. Okay, you just don't get up and start digging. Are you okay? You have to do a lot before you can even decide to dig. So it's very a risky venture. People think you just get up and mine. Geological plans, geologists map rock types, faults. So that's different from, the mineralogy of the place. Okay, a geologist may look at the area and then look at the, for what are we having here? We are digging through the Permian, and there is a strike here, and the whole of technologies that are used in the area that you need to capture that as well. Okay, because so if you don't get to know the subject area, you wouldn't even appreciate. Are you okay? What happens? In fact, all engineers were supposed to do something called geology, engineering geology, which I don't know if they're taking it out of the syllabus. Like, you would have been able to relate to what I'm talking about, but I don't know if it's still in your syllabus. So faults, faults. Let's not forget that the whole earth is made up of, rocks, and some of these rock kind of extend, and so we have this kind of crevices in between and all that they call faults. Are you okay? If there's a fault, I don't want to describe what fault is, but these things can be captured on a plan. All right, dikes and other structures. We can talk about all of them. We can also talk about geotech features. You see, the geotech really, they want to really understand like the rocks. Then again, going to geotech, I don't want to talk about geotech. It's something I think you will learn as civil engineering students, or probably you have studied it. I don't even know. Ventilation plans, essential for underground mines to maintain up-to-date ventilation plans showing a minimum direction of airflow. So we need to know, we're going down there. Can you imagine yourself down there? Like, you study a lot, isn't it? Maybe before I go underground, I'll read a lot before I go, so I know what to do. Ideally, ventilation survey results should be recorded at interval. Such maps are not easy to draw. Not everybody can draw a map showing airflow. Okay, so let's take note of that as well. But obviously, it has to be done with the right symbology. Air volumes, temperatures, pressure. Are you okay? But usually, use points, lines, and then what we call rasters. But maybe not now. But now, I just take note of the fact that there's something called a ventilation plan. That's got all that going on. The plan should, I'm tempted to ask questions around this, but anyway, don't worry. Around the mind, or maybe a whole case study on this, and then all questions will revolve around it. Okay, anyway, you never know. The plan should show positions of all fans and direction of discharge, and location of walls, doors, regulators, measuring points. So this is a whole sections through workings or appropriate place. I said, when it comes to mining, if you don't like 3D, you just say, thank you, sir, I'm out of here. That's mining for you. Mining and exploration. I mean, literally. You just simply have to do 3 dimensions, 3D. Everything has to be looked at in 3D. It makes sense, because you saw Kwame here, you saw Amma here also. By the next minute, they will be at the same place, but you can't find why they're going down to a different elevation or level. Okay. All right. So sections are important, just like roads for roads. Are you okay? When it comes to road construction, remember that we had a cross sections, we have longitudinal sections going through the same way for the mining. Are you okay? So here I just put this from the internet for you to appreciate, the kind of map that we're making. These are not the normal maps you have, which represents things on the ground that you can see, buildings and things like that. You've seen other layers. Okay, here you can see that it's pinky. The ladies are very good with these colors. Are you okay? But it's looking like pink to me. We have a different, if you like, geology. Are you okay? than the yellow areas. Okay. And the lines also have their own interpretation. We have limits of the main train, stream limits of train. So there's a train moving. Remember, anytime we talk about the railway system in Ghana, people say that's what the white men were using to transport the goods and to get it out of the country. And when you look at the design, it seems that's true, isn't it? All right. So it's fine. It's a lesson, eh? Once bitten, twice shy. First cut is the deepest. All pebbles until all pebbles, it means something to them and they can work with that. So there are minimum regulations, but you can go ahead and, of course, pay your needs. Are you okay? Representation of these are like things that you should be able to relate to. Yeah, these are lines representing maybe could be false, could be, are you okay? What the interpretation may be, just like the other one that we just looked at. All right. So basically, that's that. Large mine operators may employ more sophisticated techniques, okay, for surface, including aerial and satellite mapping. So you can use area and satellite mapping. Okay, so satellite mapping is like remote sensing, which we want to talk about if we have time. I mean, let's just see how we go with this one. GPS and other drones can also be used to map. Okay, ignore ASM. All right, so yeah, of course, depending on how you do it. Are you okay? Surface survey control. Okay, so we're talking about using GPS to extend control. Are you okay? All right. We can use theodolites. Are you okay? We can use total station. Remember that the total station is an electronic theodolite. It's able to measure distances electronically and then to measure direction as well. You can't use any system that requires satellite underground. Are you okay? You're going to have issues. So as you can see here, underground GPS and aerial methods are not applicable. Okay, and the survey is carried out with total stations, theodolite and things. So here you need a surveyor. Okay? There are people who are using GPS and they don't even understand, you know, how it works, but they are using it. That's what's going on. We are in Accra. Everybody's doing what they want to do. And as long as you give them money, you get to go with less enforcement of regulations, okay, and no law to back it. People can just get into, everybody can just jump in. Are you with me? All right, so we should take note of the fact that satellite methods, GPS uses satellites. It won't work underground. So you go in there with your total station, switch it on, make sure you have battery, and you start turning angles. Are you okay? Etc. And you'll be good to go. All right. All right. So the challenge is with the verticals. Are you okay? The challenge when it comes to underground surveying is the transfer of coordinates from the surface to the underground vertical shafts. Is that okay? All right. And also, like you're saying, the shaft dimensions provide very short baseline. What is the shaft dimension? Is like the space. You see, when we look at the first diagram where you saw the shaft, it was pointing at a certain place and it's saying that's where the shaft is. That's like where you are going into. It's like going into a story building and then they're going into the lifts. It's just a small area through which you get down, isn't it? All right. So we're saying that that space is too small for you to draw a baseline. Normally, a baseline should be very long, isn't it? All right. So that is a short baseline on each level from which surveys must often be carried for long distance. Think about mining survey as, like I said, a story building in which you're going down. And at any level that you get down, you can now dig something. Okay, that is how it works. And they got train and stuff like that, like rails underground that they use to transport the material. So that is why it's important to consider vertically how you transfer the coordinates. How do you transfer a coordinate? Naturally, you have a baseline, so you have a coordinate, you have another point where you are, which you also know the coordinate of it. You measure to it. to get a distance. You take a direction to it. You turn your theodolite at a certain angle, and then you point at the point of interest. Then you can now measure the height or get a coordinates of the new point. But here we want to just go down. So even though we've established the coordinates within the shaft area, going down, how do we transfer the point, the coordinate down there? It's a challenge. Okay. All right. And now we're saying that shaft dimensions provide a very short baseline on each level from which service must often be carried for long distances, sometimes several kilometers off a base of as little as 2 meters. I get that. All right. So that is basically the challenge. Shaft plumbing is a tricky task. Are you okay? What it means is that you set up a theodolite, set up a total station, and then you need to now put what we call the plumb bob. Are you okay? So you put a plumb and then you just drop it. Are you okay? And then you put a heavy metal at the end of the plumb line so that it is straight. Is okay. Then you have to now measure a distance. Are you okay? All the way to the level of interest. Are you okay? And it's tricky. Yeah. It involves suspending 2 thin wires on plumb bobs from surface to underground stations or between 2 or more shaft stations, measuring angles of the 2 wires as well as the distance between them, the vertical distance. So, you know, it's subject to some errors because the distance is really small. Okay, so so that is the challenge with underground survey. All right, so it can be a lengthy process as well. Okay, the use of the shaft plumbing is okay. Can be a lengthy process, disruptive to the shaft sinking or production activity. Okay, because I'm doing this work, and then we got people actually going in that shaft at the same time. Think about it that way. All right, and that's the access to the mine, isn't it? Where else were you going to do that? How are you going to enter the mine? How are you going to transfer content to the mine without going through the very entrance to it? Okay, so normally when people get stuck in a mine, it's just one place they need to come out of, and so if it gets blocked, then I think there was this, it's Cuba keeps coming in mind. There were some miners, underground miners, who got stuck, and it took how many days? 30 days. People were flowing and they were down there. You know, when they came out, they had to, you know, cancel them and all these kind of things. Okay. So pegs are installed by surveyors for control of direction and gradients of fancy development headings. Is that okay? So the development headings is, if a heading is now talking about direction here, is that okay? So just the semantics. You can also use lasers. So lasers may be installed by surveyors to assist miners to mark for trailing along the plan line. The thing about lasers is that once you set it, like I said, it just throws this red light and the laser, right? So laser looks like red lights, but there are 2 different things. On the Leica instrument, the red light is there, the laser is there. If you are not careful, you go and look at the laser, it can affect your eye. Are you okay? Don't forget they use laser for eye treatments. Okay, they use it to cut and things like that. Be careful which one you're looking at. You don't go and destroy your life whilst you're on a salary of $10,000 a month with one eye. Anyway, so that's not funny. So you can use laser set, but the advantage of the laser is that then you can just leave it there for the miners to work with it. They know exactly, you've said it already. They can now, okay, know that, okay, if I get a reception of the laser at this point, I know I'm at 1 meter, I'm at the certain design level. Are we on the same page here? I think Equia can relate to this. Yes, those who have not been coming, they can't. So this view is just nice, isn't it? Yeah. This is it. This is all I have for you on this. Maybe we touch on the ways back method, which is really, you know, solving for the bearing, finding the bearing of a certain line underground using a triangle, which is not like a scaling triangle of unequal sides. Are you okay? All right, and angle as well. Okay, so but then this view is quite interesting. You can see the order that I'm talking about. This is the picture you should have in your mind. Are you okay? You can see the heading in there. All right. There are areas that have been mined out. So we need to indicate that you need to take note of that there are different areas in there. There's a shuttle car. Are you okay? That takes you. So I think Ekia will be going there after this program. Is that not so? Ekia will be going down there. Are you? Yeah, she just replied in the chat because of the video. But yes, there are rails down there. Are you okay? I can see some ventilation stuff's going on up there. Okay, and there's a main shaft. A whole lot. I mean, seriously, you make a lot of money working here, but that's not why I'm here. Anyway, so basically that's that. So the waste back method, briefly, let's look at that, then we just go. All right, so let's look at the waste back method briefly, and then let's change the topic. Is that okay? You don't have time, but the time just flies once you start talking. It just goes quickly. Grammarly is your personal. So just be with me. I'm trying to just get something for you. Okay. So if you can see the video that's playing. Okay. So pay attention. It's a very 5-minute video. Just watch it. There we go. Oh, that's. Okay, so let's continue on the other side. Okay, let's rejoin. The session is ended, so let's cut it. I'll let you watch this video again. Okay, so thank you very much and let's see you